So first of all, thank you very much for having the opportunity to speak at this event. I thought as a chair of the GAI, I'd spend a little bit of time talking about where geothermal usage in Ireland is at the moment, and perhaps looking at the role it could have in retrofitting buildings and decarbonising particularly heat production. So what I'd like to do is spend a few minutes talking about where we are today, and given that this week is a Shallow Geothermal Energy Days, European Shallow Geothermal Energy Days, give you some flavours in terms of the current state of the art in including geothermal in buildings from around Europe. And then in the last part of my talk, I'll give you a little bit of an outlook of where the Geothermal Association sees geothermal towards 2030. And this is part of the work that we've been doing in completing our draft strategy, which will go out for consultation at the start of next year. So there's a slide here about the GAI, which was an all-island organization, given the lack of borders, as were highlighted beforehand from a geological and geothermal point of view. So it was formed in '98, mostly for the promotion, education and creating awareness of geothermal resources. And we have a number of affiliations with other organizations, and there are some benefits. I probably don't have much time to cover that today. A little bit about myself. My own business is GeoServe. We specialize in geothermal consultancy, and particularly in offering turnkey design, build and operate solutions for geothermal collectors, for ground source heat pumps, and anything that's residential or commercial. And if there's any of the type of systems you see on the talk today that are of interest, please don't hesitate to get in touch. So where is geothermal in Ireland at the moment? Well, our official recorded installed capacity that we know of in total is about 191 megawatts thermal, and it all comes from ground source heat pumps. And as you've heard today, there's been historical I suppose, exploration and research of geothermal resources dating back from the 1970s. But to date, we have pretty much no direct utilization for heat, industrial process or power. So if you were to fly around Ireland looking for, how we harness geothermal energy, these are the things that you might see. Large buildings newly constructed or under refurbishment, using very large scale horizontal collectors, as you see in the picture here. And you might also look at other areas of the country where we might be using open loop boreholes, so producing water from existing aquifers and gravels. This is the Glucksman Gallery in Cork, a building that has won quite a number of architectural awards. And that basically uses groundwater from the gravels from the River Lee next door, where there are two boreholes just outside the building, providing simultaneous heating and cooling to a 200 kilowatt heat pump inside the building. You could look at the residential sector, and you could see this as a typical picture of where you might find ground source heat pumps, mostly in less dense urban areas, so more out in the countryside, associated with other renewable technologies such as solar thermal or PV, and using boreholes or horizontal collectors. So what I'd like to do now is move a little bit beyond sort of where energy or ground source heat pump utilization might be in Ireland, and look a little bit around Europe and see where the current state of the art is, and what vision there could be for the island in terms of changing the way we see geothermal and maybe integrating it better into our building structure. So the first area I'd like to bring up is the area of geostructures. They're very seldom talked about when we talk about geothermal energy, but in reality, these are integral parts of building construction and renovation. You can see a picture of a CFA pile about to be installed in the lower picture there, and that has a ground heat exchanger strapped to the main pile cage. And above that, you can see retaining walls where there are geothermal installations, and you can see also basement slabs of similar buildings. So an example of this comes from Austria, which was presented at the start of the week. This is the Marina Tower building in Vienna. They're basically apartments. The site is about 50 by 70 meters in size, and it's adjacent to the River Danube. And you can see that the geothermal solution there has been to exploit the actual building itself and the construction of the building itself. These active slabs, which were installed in the bottom part of the building, which you can see in the bottom right there of the screen, were actually provide 50% of the heating and cooling demand of that building. So the building actually sits, the resting water level for this building is actually 10 meters above the location of the basement. So we're essentially in the aquifer, and we're just changing our thinking in terms of integrating it into buildings. So there are various other solutions for harnessing shallow geothermal resources. You've seen some of them mentioned already by the previous speakers today. There are various solutions for horizontal collectors, such as baskets or capillary mats. There are now solutions for integrating harnessing of energy in sewage pipework or discharge pipeworks. There are different types of vertical collectors, standing column wells, or indeed higher heat transfer steel-based collectors combined with high temperature heat pumps for more difficult to retrofit buildings. So these are all things that are there. If we move on then to the concept of some of the things that were talked about by the previous speakers, you can see here, this is an example that comes from Denmark, and the slides are courtesy of Thermonet. And this is the concept of shared arrays. So rather than putting in complete district heating networks to actually circulate and share the heat, here the concept is to actually share the energy harnessing infrastructure in large, let's say, large housing estates, like you can see in the bottom picture there, where there are a series of boreholes, and the individual homes have each individual heat pumps, or at a much larger city or town level, which is very much how these are being implemented in Denmark. So not in dense urban areas, but probably in more peripheral towns, where the infrastructure for actually harnessing the geothermal resource is shared. So again, low temperature networks. You can look even further than that. This is really a slide an image that I like quite a lot. This is the vision of Stadtwerke München, which is the German utility of Munich, of how they harness geothermal resources, and that's their plan, and this is the plan that they're trying to implement. On the right-hand side of the picture, you can see a very new 6 geothermal doublets system that has been completed from the same drill pad in the city center of Munich. And these doublets provide about 100-degree water to a high temperature district heating network, which provides heat to the more difficult to retrofit buildings, all areas where low temperature heating may be less possible. But the city also recognizes the need for low temperature networks. So on the left-hand side of the picture, you see the schematic of their low temperature district heating network, and that uses existing aquifers, shallow aquifers, for heating and cooling. So if we look at buildings, I think a lot of this has probably been covered already, but what are the pros and cons of geothermal? Well, really, there's quite a lot of pros if we compare them to other renewable technologies. So first of all, geothermal can offer high efficiency heating and cooling from the same plant infrastructure, and that's really important. So we're not talking about providing one infrastructure for heating and a separate infrastructure for cooling. We can actually do it with both. They're highly scalable. These can be integrated to high temperature district heating networks or low temperature district heating networks, as we've heard. Typically, the infrastructure has a very long life expectancy, probably contrary to other heating and cooling renewable technologies. Some of the cons, obviously, it's much higher capital intensive, and it requires detailed planning and design. So during the course of this year, we've been trying at GAI to look at, where might be the low-hanging fruits, and where would geothermal on the island best fit, and we've looked at a number of possibilities and opportunities, and we believe, I'm saying this for Northern Ireland, but in reality this is really the strategy that we see for the entire island. So we see the low-hanging fruit for us is the retrofitting of commercial and public buildings first. So the larger schemes. There are obviously possibilities with residential systems, and maybe I'll cover those a little bit later. But if we focus on commercial and public buildings first, where heating and cooling loads are generally present, as retrofit tends to look at NZEP standards and developing much higher levels of efficiency, we actually see in the building stock and in the retrofitted building stock that there are cooling loads now that perhaps did not exist beforehand. And then in terms of district heating, we certainly see a potential for deep geothermal, aquifer thermal energy storage, and borehole thermal energy storage. And you've heard about some of these this morning, and I think you will hear some more in the next session. So if we look at Northern Ireland and we look at the Department for Economy's work on the energy strategy, we believe from some of our members' consultations with DFE that some of the estimates in terms of the buildings that might be refurbished in the future lie in the figures that you see above. So what we're saying is we'd like to try and be realistic, and we'd like to say, well, if we look at the next 10 years, where would geothermal fit best? So we're saying we'll focus on commercial, public sector and tertiary buildings first. We'll focus on baseload heating and cooling options, and we look particularly in the context of deep retrofit and displacement of oil-fired central heating, integrating geothermal with other renewables. So if we look at that and we consider taking that 10% chunk of buildings that are refurbished every year, for the moment we're not considering residential potential, but there is more there. This is what a sort of a picture to 2030 would look like. So you see on the left-hand side of the scale, this is the average growth rate of ground source heat pumps at the moment on the island is about 3.8% per annum. So what we're saying is that starting in 2021, 2022, we'll be moving to 4%, and we'll be increasing that growth rate all the way up to 10%. And if we then look at the building stock that there is, we consider that there are deep retrofits. So a lot of these buildings will try to achieve probably only 1,200 hours of heating or 1,400 hours of total heating demand. They may have a small cooling load, maybe something like 260 or 280 full working hours of cooling per annum. This is the typical spread that you would see from commercial buildings only. So these are figures for the all-island market as we see it, so including north and south. I probably don't have the time to cover this at the moment, but I'd be glad to talk about it to anyone afterwards. So what's the potential for deep geothermal? And I'd like to stress first of all that the table in the slide here only covers heat. So we see the vision is definitely in the context of district heating in high heat demand areas with a high preference, industrial applications like have been covered earlier on, and then there is some potential probably for power generation, but at the moment we need to better understand where this would be and how it would be implemented. So if we look at heat alone, And we take into consideration that let's say the development timeline of deep geothermal projects tends to be quite long. We might see a type of sort of number of plants in operation, as you can see here, over to 2030. This might be the structure. So we're saying let's be conservative. Let's assume that we have an installed capacity about 5 megawatts for each one of these plants. And we would end up with probably about 20 megawatts or so spread out across the island by 2030. So this could still be conservative. We could accelerate this much more, and we could have this plants under investigation line here at the bottom actually much more developed in the course of the next 10 years if we get the right policy framework. So for my last slide, what's needed to support it? Well, I think we've heard a lot about that already, certainly in the first session this morning, and probably to some more extent earlier in this session today. But I think one of the key things that's critical, and I suppose apart from increasing the resource awareness and the public perception that comes around geothermal, we also need a more careful planning of energy demand and resource matching. So I think the piece of energy demand and resource data for Northern Ireland really needs to be further highlighted. An integral part of this policy making and this support is the development of system related data. So measurement, monitoring and verification. And for us, this is critical. It's about being able to understand where systems are located, how they might be able to interact, and about better informing planning decisions and energy planning in the future. There are a few others items that I've included there, but one of my favorites is the fourth item, which is integrated design. And when I say integrated design, this has to come from a local area level in terms of how one wants to develop energy solutions in a local community, all the way down to looking at the building fabric and integrating renewable technologies and geothermal with the building fabric and the retrofit. So not applying this current model, which we still see a lot of, where there's a proposal made for a building, for a refurbishment of a building, and then there's just a bunch of other technologies or renewables glued onto it to achieve a certain maybe BREEAM standard or a certain DER rating. So really we need to look at a much broader approach. So I think I'll leave it at that. Thank you very much.